Hi, once again, everyone. It's Professor Sebastian. Welcome back to our statistics class notes. We're in section 6.2, talking about the normal distribution, and we're in the middle of page 85. So now I want to talk about going, quote, backwards, finding x values, finding the random variable x's values when you're given a probability, either a probability that it's greater than or equal to something, or a probability that it's in between two values. So sometimes we're interested in finding the value for the random variable x associated with a given probability. So for example, let's find the value of k. So k is our unknown here, for which the probability that x is less than or equal to some value of k, that's what we want to find, is equal to 0.9. So it's a 90% chance that x is less than that value of k, given that x is normally distributed n with a mean of 70, standard deviation of 10. So I'm going to do the sketch first again, and I'm going to quickly sketch a normal distribution of 70, 10, mean of 70, standard distribution of 10. So I give myself a bell curve. I know the middle is 70. Now, I'm not going to always clutter my picture up with 3 tick marks to the left and 3 tick marks to the right. I know that the area I want is 0.9, 90% of this area, which is 1, right? And it's to the left of some value of k. So k has to be over here to the right of the mean, because the area to the left of it is 90%, which is much more than 50%, which would be at the mean. So since I'm 90% area here, k has got to be over here to the right of the mean. And that's all I really know to know if I'm putting things correctly into StatCrunch. So now here's how you do it in StatCrunch, but let me go quickly over there and show you. So now we're in StatCrunch. I'm going to go ahead and edit this. So the mean we want now is 70. Oops, sorry. 70 with a standard deviation of 10. And I want the probability that x is less than or equal to some value of k, which I don't know. So that is what I'm going to leave blank, because that's where the answer will show up. And on the right-hand side, I'm going to put 0.9, because I know the probability, 90% or 0.9 probability. And when I hit compute now, the k is going to show up right here, and I'm going to match my picture to the one that StatCrunch gives me to make sure I thought about it correctly. So it looks very similar to what I put in my picture. So the k value right here is this guy. This is what I'm looking for, 82.815516. That's the k. That's the value of the random variable x. So that the probability that x is less than or equal to that value is 0.9. If you go back, I put that right in here. I wrote it as 82.815516, the whole thing. So let's put that in context of an applied example. So let's go back to our seal pups, our harbor seal pups. And suppose that x, the birth lengths of newborn seal pups, follows the model normal distribution with a mean of 29.5, standard deviation of 2.5 once again. And suppose pups with lengths at the 15th percentile and below are unlikely to survive. So what birth lengths would make it unlikely that a pup would survive? So again, I'm looking at my normal distribution with a mean of 29.5, draw my standard bell curve. And I know that the area that I want to figure out is where to the left, I'm really small pups, right? So I'm talking about the 15th percentile, where only 15% is less than them. This is the birth length, that anything less than that, they'll be unlikely to survive. So this area is 0.15. So now I'm looking for that k. I'm looking for the probability that x is less than or equal to this value of k, which I don't know, is 0.15. So if I go back to my normal calculator, I need to change my mean to 29.5, change my standard deviation to 2.5, and this is what I'm leaving blank. But I'm putting the area, so this is where k is going to show up. The value of k that harbor seal pups, where their birth length is that or smaller, right, less than or equal to, they'll have a hard time surviving, and we know that's the 15th percentile. So the area there is 0.15. So now I hit compute, make sure it looks like my picture. Yup, it does. So that birth length, where anything less than that makes it hard for the seal pup to survive, is 26.908917 inches, or I think it was centimeters. I'll have to look again, I forget. Let's look. And that's a cut and pasted there, so it's inches. Pup lengths less than 26.9 inches, and when I round off to 1 decimal, at birth are unlikely to survive.